computer. There we go. Okay, well, welcome to today's class for 6950. What we're going to do today is we're going to continue doing some Python. But before we get into that, I just want to review the previous assignment, or the one that many of you sort of submitted to me and sent me a note on Slack about in the last several hours. Thank you very much for that. So basically, it was just all of the exercises for number one. And so I'm looking for a volunteer. I have a tiny little participation mark, and all I need is someone to talk about their Python assignment, specifically showing, I don't know, your code for report.py or whatever it was. So can I have, out of the 10 people who are here, a volunteer who has not yet gone before? Who's talking to me?
Mohammed.
Excellent, Mohammed. That'd be great. So if you would just share your screen and show us your report.py, we'll talk about it for a few minutes, and we'll call that your participation. That'd be great. I appreciate it. Okay, so
let's go from the start.
Yeah. Now. So yeah, well, let's just take a look at your code, mortgage.py and pcost.py, right? Those two programs.
Okay.
Right. So let's just talk about those for a moment. And this is partly for me to ask you some questions, but it's also to remind the whole class of what we've been doing. So what does this mortgage program do? Do you remember what its purpose was?
Yes, that the user has to pay, and with interest rate, rate, and the payment every month. And we keep track of the total paid amount, and there are other variations in the later exercises that at the end we have to print the table, what was paid each month, and keep printing the table until the end.
Okay, so this is your finished sort of program after all of those things have been added. So I see you have a bunch of lines that initialize some variables, and then, okay, thank you.
Okay, I can go through them, or?
Sure, I think we know what all the variable names are. Okay. Let's just talk about, okay, so there's a couple things, right? So we've got, you're basically got the while principal is bigger than 0 as the flag, right? So the program keeps on going until there's no money left to pay.
Exactly.
Right. Now, how much money do you pay every month?
First of all, it's from this equation, but before we calculate it, there is an extra amount that must be paid starting from that month until that month.
Yep.
So before calculating what will be paid that month, I check on that condition first. If the current month is bigger than the month and less than the end month, we will say that this month extra payment equal to the extra payment that should be paid. Otherwise, this extra payment will be 0. We won't pay any extra money this month.
Okay.
Then the principal is easily the principal that has to be paid multiplied by the interest rate, because we have incremented a month, so the principal increases, and we subtract the payment that we have to pay each month plus the extra payment that we have to pay that month. If we are between these two in the range of the start and the end month, this will have a value, otherwise it will be 0.
Okay.
And the total paid, we increment the payment that we paid that month, and the extra payment that might value this month.
Okay, and so what are lines 26 through 28 doing in the program?
Well, basically, there is no guarantee that we will reach 0. We can go below 0. so we can pay more money than we should. So after we finish, either you can check on this condition before your solution, but it's much easier because you just say if its principal is less than zero. If you have went below zero, the principal will be negative. So negative the principal will be the amount that we have to compensate for. We will just remove it from
Right.
the total paid and just add it and remove it from the principal as well.
Right. So at
Or
the
add it
end
to the-
of line 28, you're guaranteed that the principal is going to be equal to 0.
Yeah, because there is negative, we are adding its negative to itself, so it's going to be 0.
Okay. So you could do that, or you could say principal equals 0.
Exactly.
Okay, that makes sense. Because lines 26 through 28 are a little odd. If you like, I know you wrote the code, but if you imagine someone else was reading the code, I probably would put a comment above line 26
Okay.
to explain that what you're doing is handling the case of a negative principal, or like ensure we're not overpaying, right?
Yeah.
And that's just helps a reader understand what that particular block of code does. And then the last bit is you've got a table. Let's just talk about what the different symbols in the table mean. So maybe you want to run your program and show us what it looks like.
Yeah, sure. Oh,
You're already in the work directory.
okay. Um, okay,
Nice.
so here's there's a lot of lines, so let's go from the beginning. So
Yeah.
here's the number of the months passed and the currently paid amount and what remains from the principal.
Right.
So
okay. So the first comment I would have is in terms of doing this, the tables should have headings.
Okay.
Those features. And then what does the little, we call it a caret, the upward pointing arrow, what does that do to format string?
That centers it. So if you put the number, this is
Points.
Centering.
Yeah, instead of centering.
Okay.
So if you look at any financial statements, you'll see that what they do is they line up.
Okay.
So well, no. So that will left justify, right? Correct?
Yeah. Now it's left.
Yeah. So you don't want to left justify. You want to typically right. Okay. Right justify, which is the default. Yeah. Now you can left justify the month. Left justify, but it's just so you can see the numbers because the centering's sort of cool. Okay, that's fantastic. Great. Okay, I think this is a pretty straightforward program. Does anyone else in the class have anything about the mortgage.py exercise that is a question or like, well, why do we do it that way? And hearing none, let's just look at your PCOS program and do the same thing.
Okay. So here in PCOS, so it loads a CSV file and it has a bunch of stocks in it. Each row has a stock name, and the number of shares, and the stock price. And we have to calculate the total price of the stocks included in the CSV file.
Yeah.
So here I just import CSV to read the file and system to read the arguments passed to the command prompt, because we can launch it from here instead of hard coding the file name. So what I'm doing
Okay.
here, it's a function that takes the file name, and uh, I know this is not the way that was explained in the lecture, but I keep track of the line number, and
Okay.
I suggest line instead of using next, because I usually work in Jupyter Notebooks interactive. So next, and if I use next and run the same cell a couple of times, I can mess up my code. So I usually prefer to just loop over the lines and skip the ones that I wouldn't want. So I
Um,
just initialize. Yeah.
okay. So I understand that, but two things. One is you'd never run this code by itself. So I totally understand working with Jupyter Notebooks, but you have a
Yeah.
block of code, right? So lines 13 through 26. You could think of that as a Jupyter cell. So it would never be run by itself. So using next is okay. And the second thing is, if you look at the documentation for CSV.reader, is there a way of skipping
Okay.
headers in that? Or is that only like in pandas.read CSV?
Um, the,
No, they don't have that. They got rid of that.
okay.
Yeah, but you because you're a pandas user, right? You know that if you
Yeah,
were doing this in pandas, you can just skip
I
headers.
can just remove that. Yeah.
Yeah, but so I understand why you've done it that way. Again, what I would do though, and this is not just this program, but in general, put some comment in above line 19 saying or why you're continuing, right? So why are you
Okay.
continuing? Because you're skipping the header,
Uh,
right?
it's the first line slash
Yeah.
header.
Yeah. So that's just that better code. So that makes sense. So you're using the reader. Okay, so we didn't talk too much about CSV reader, but you were supposed to go and do it. What does
Yeah.
CSV reader return? What kind of data structure or data type is CSV reader giving you?
If I remember, it was something like called string object or something like that. I
Okay.
know that it's I thought before reading the type it was a stream, like an input stream. But when I
Well,
checked for it,
yeah, it's not a string.
yeah, it's a stream, basically input
Yeah,
stream. So we can,
it's a stream. So
yeah,
Python supports this idea of any sequence that has the idea of a next. So lists have the idea of a next, but streams also do. They're called iterables. So there's a first
yeah,
thing, a second thing, and anything that's iterable, you could loop over. So what CSV is doing is giving you an iterable. And then each iterable is a line, okay? But that line is not a string, right? So what you call the variable line, L-I-N-E, that's not a string. What data type is that line?
that line right here.
Yeah, the variable line. What type of variable is it? It's not a string.
Yeah, it's an iterable.
What lines is an iterable? What's
Yeah,
line?
it's the next item in the iterable. So may
Right, but
it be a string,
what
a
data
number, or what?
what no, it's not a string or a number.
It just takes the element of the sequence, the iterable, whatever it is.
Right, right, but in this particular program, it's not a
Yeah,
number, it's not a string, it is a what is it?
I check for it. Uh, okay.
Someone can help Mohammed. What type of uh, data structure or variable type? Yeah, exactly. Take a look at what it actually is.
Okay. Bcast. Okay.
Yeah,
It's a yeah.
it's a list.
Oh, because yeah, because CSV already parses the lines of the text file, and each entry is an element in this list. Yeah,
Okay. And the reason I ask is line 23, you're doing unpacking,
exactly. Yeah,
right? So you're assuming when you do line 23 that
it's
your
a
list
list
has
already.
3 items in it. Okay. So we talked
Yeah,
about tuple unpacking. Python also supports list unpacking, where the 3 elements of the list are mapped to those 3 variables: stock names, shares num, and stock price.
yeah.
Okay. What does line 23 through 27? What's going on? What's the purpose of that block of code?
Well, here we try to take the second entry and the third entry in the line, which is just uh, which holds the shares number and the stock price. And here we try this piece of code. And
Okay.
we tried because there might be missing values, like the shares number is not known or the stock price. So this would give an error. Float of just an empty string. Let's go to Python.
Mm-hmm.
Will give an error. So
Okay.
if we don't it will give us an error and stop the program. So try to do it. If it raises a value error, you just print a message. We can also raise a warning, but if you also the traceback, which can be a lot to show. So just to print a nice message that missing field encountered, skipping the corresponding line.
Right.
If
But you
all
don't
goes
actually,
well, yeah.
yeah, I see. Okay. And in the data, are there typically missing shares or missing stock prices?
In the file specified in the
Yeah.
exercise, I found another file that was added that had missing
Okay. Nice.
entries.
Okay. That makes
I
sense.
believe.
And the no, that's great. And the very last part of your program, so you defined a function and it returns this variable all shares price.
Yeah,
What data type is all shares price?
it's a float because it's
Nice.
multiplied
Okay.
by integer and the float.
Okay.
Python will convert it to a float.
Perfect. Perfect. And the last part of this script, just scroll down a bit more. Oh,
So
cool. Okay, I like what you've done with 31 through 34.
yeah, so I can grab the file name from the terminal. So
Right.
it will check for that exactly 2 are given to the terminal. The first argument is always a script name, so we don't use it. The second argument is what we want, which is the file name. So data, I don't remember what was called, portfolio, yeah, .csv.
Yeah.
Yeah.
Nice.
So it takes it. This is a file name, calls a function, and just print the cost. And the other file that was missing, I believe it was just called missing. Yeah.
Yeah. Yeah.
Yeah. Field encountered, skipping the corresponding file.
Nice. Nice. So the only other comment I would have is when you get down to line 38,
Okay.
why did you just use a print and you didn't format that with 2 decimal points?
It's just one variable, and it's at the very end of the string. So yeah.
Okay. So remember that floats, not all
Yeah.
floats can be resolved perfectly, right? So it just so happens that your math ended up with a float, which was 27,381.1500000000,
Okay.
right? So it
Got
looked fine. So
yeah.
it just, yeah, it didn't matter in this case, but
Yeah. Makes
as
sense.
you think about using the idea. Beautiful. Okay. Again, does anyone else in the class have any questions that came up as they were solving this these exercises in this first chapter? Is this all pretty, is it easy? Is it like any questions about Python that came up? Any questions about programming that came up? Thanks very much, Mohammed. I appreciate that. Thanks very much for
Thank you, Professor.
showing us what you've done. Okay. Okay, so I will continue on here. And I will share what I'm working on. So what I have here is the next, oh, let me scroll to the top here. Okay, so we sort of done the introduction to Python, and now we're going to talk about a few other things. My memory was last week we talked about lists and dictionaries and sets as ways of holding on to data. I've asked you to sort of go through this and learn about how to format things. Now, this is something that exactly what Mohammed just talked about, that when we're formatting strings, we can format them like left justify, right justify, and there's a lot of ways of formatting that data. When you're formatting strings, you can format them the way that we've been doing them, like so far, which is it's an F string right in there where you put the variable name and then the formatting code, whatever you want to use. There is a way of applying dictionaries to these strings as well. So if you have a dictionary of information, so a whole bunch of fields, what you can do is another way of creating that F string is to say, okay, well, look, here's the string, and what I want you to do is display this whole dictionary S according to this string. So it's similar to an F string, but not quite. And finally, format is another method that operates on a string, which is effectively the same as an F string. It exists, I think, because that's how F strings are implemented, but no one ever uses them. You will see in code, established code, this notation. So for a long time in Python, this was how you did string formatting. So what would happen is if you wanted to replace a character, like if you wanted to have the number 3 appear right here, or some variable appear right here, you do what's called C-style formatting. If you're familiar with the printf function in C, this is how symbols are formatted, either with %D for 5 spaces or %.2f for floating points, and they use the module operator to fit this in. In older versions of Python before version 3.6, this was common. And so you're going to see in historic Python code, this kind of stuff written out. You're going to see it in tutorials based on Python before Python 3.6. And it was the way people did it. It is not as clear to read. If you're good at your C programming, then this might be great for you to recognize that $D5, $D5, $10D will turn into this string, but I don't find it as clear. So as I'm doing new Python programming, I have switched almost entirely to F strings or format maps everywhere in my code, but you'll see it in historic code. Okay, so there's some exercises for formatting. And what we're working on here in this chapter is a program called report.py. So what Mohammed demonstrated was P-cost, which was the cost of a portfolio. What these exercises are going through is making up a program which takes both a portfolio and a set of current stock prices and makes a report that gets displayed out. And you can imagine this as being the internal business logic for some sort of financial stock trading portfolio. It doesn't really matter if it was being displayed to the screen or these functions were generating some web page. You can imagine some finance site wanting to show you what your current portfolio is worth in terms of stocks. These are the basic pieces that you would need inside the business logic, the actual code, to make something like this work. Again, when we're talking about formatted tables, here's an example of doing it with C-style strings, C-style formatting. You can also do it with F strings. And so you can decide whether or not this code is easier to read or not I find this very hard to read. Okay, I shouldn't say that. I find this very hard to read when there's more than about 2 or 3 columns. There's times when you have 18 columns, and this can be incredibly hard to debug when you've got strings and integers and floating points. I find F strings to be very clear and very easy to read, even though they're longer to write out. There's something about programming, right? That even though it takes time to write this out, to actually type out these characters, you're only really ever going to type out these characters once. But you're going to read this code, or someone else is going to read this code many, many times. So it's worth the effort to make your code readable. This is far more readable code than this code is, and more maintainable all the way through. Okay, so we talked about headers. I was giving Mohammed the recommendation that you should put in headers. This is exactly what this exercise asks you to do, is when you're printing on a table, go ahead and put it the titles and put in lines underneath them just to make it look a bit prettier. You want to put lines, as in horizontal dashes, underneath. Now, a trick is with formatting, you want to make sure that the number of hyphens you use is the same as the width of each one of these columns. And so one of the things you can do is, you know that each one of these columns has a fixed width. What do I know the fixed width is? Well, I can set it. I can say each one of these widths is 10 digits wide. So what I can do when I go to print out this string, I don't need to actually have 10 asterisks all beside each other. 10, like hitting the keyboard, hyphen, 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 hyphen. When you go to print this out in the code, what you can do is have a single hyphen, then multiply it by 10. So you have 10 hyphens, and build up this string as a program. And the advantage with it is, if you at some later time need to change the width of these columns, everything would automatically adjust. And so there can be a value in writing your code so these things are dynamic in terms of how long it is. I don't think there's anything overly interesting to talk about here, but I want you to work through this exercise and try and get this program to produce this formatting challenge. And again, if you haven't done the first 11 exercises, you have to do those first. The idea is to talk about formatting. So let's just continue on and talk about some more Python things. Okay, we talked about different data types. I talked about iterables. Okay, another word for an iterable, well, not exactly true. A sequence is an iterable, but not all iterables are sequences. Sequences are things that are iterable. There's a concept of a first, a second, a next. You also, in a sequence, can do lookups. You can say, well, what's the 4th item? What's the 12th item? In an iterable, you can't always look up the 6th item or the last item. You only look up the next item. But sequences are iterables that also have the ability to just jump to a specific entry all the way through. Strings, lists, tuples are all sequences. And so sequences is something we can do unpacking on. Anything that has a sequence can be replicated. So whenever you have a sequence and you multiply it by a number, what you get is that sequence repeated and then concatenated together. So if I have the sequence 1, 2, 3, which is a list, and multiply it by 2, what I get is 1, 2, 3, 1, 2, 3, all the way through. So, and the reason that works is because sequences can be concatenated together. You can add 2 sequences together. As long as the sequence is of the same type, that works. You can add tuples to tuples, lists to lists. You are not allowed to add tuples to lists, or strings to tuples, or strings to lists. You've got to convert them all the way through. We talked about slicing when we talked about strings. It's the same idea, that if you want to talk about a subrange of variables, what you can do is you can talk about the subsequence from position 2 to position 5. Again, remember that when we're counting positions in sequences, it's 0 index. So this is the first position, the second, the third, the fourth. We would index this as A0, A1, A2. if you want to have the substring from 2 to 4, what you do is you say, I want to start at position 2 and go up to, but not including, position 5. And this is what this notation means. Start at 2, up to, but not including, position 5. One way you can think about this notation is imagine that where my cursor is, right there, call that 0, call this 1, call this 2, 3, 4, 5. And that means that if you go from 2 to 5, the stuff in the middle is what you're getting. When you use a slice with a negative, it means count from the left. So -1, -2, 1, 2, 3, 4, 5. So go back. Whoa. That was weird. Go back 5 positions to here, and then go to, and you see there's nothing on the other side of the colon. That means go to the end. Whenever you're missing the colon, what that does is it gives you the range from wherever you start to the end, or from the beginning up into, but not third position. So these slices have a concept of a start and an end. Okay, slices don't include the end value, so they're like open half intervals, and you can can remove them. Now, with these slices, if the data type is mutable, as in you can change it, so not strings and not tuples, but lists, then what you can do is you can take a section, positions 2 through 4, right? So these 2 spots, and replace it with another subsequence. So you can take a sequence, basically the same as deleting those 2 things, and then inserting 10, 11, 12 in that same location, okay? To delete something, we'd use this subsection right through here. Now, there's something that comes up whenever we start to use Python, and I don't know if it's going to give me an example later on, so I'll just do it right here. Thanks very much. You can't open it up. Sometimes when we have a string, so let's create a string or a sequence, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why not? Okay, so len of a, we got a sequence. Sometimes what you want to do is you want to have a variable that represents the slice. Okay, I'll be specific. If I take A and I say, okay, inside that A, what I want is I want the range between, say, the 5th, 4th position and the 8th position, right? That's the list. Well, what if I wanted to do a loop and show me all of the subsequences? Okay, so for example, let me say I was trying to write a program where the program was supposed to be give me 0 to 4, and then the program was going to give me 1 to 5, and then the program was going to give me 2 to 6, and so on and so forth. Okay, so one way of writing a program like this was you could have a loop where you have I is equal to some value. Okay, let's just something be fancy about this. Say 0, 1, 2, 3, 4, 5. Okay, and then what I can do is I can say, okay, I'm going to print out I colon I plus 2. So one of the things you can do in slices is they can actually be variables. Get that a bit bigger. So when you're dealing with slices, you actually can put in variables into these digits. So if you wanted to come up with a subsequence 0, 1, or 1, 2, or 2, 3, or 3, 4, this is an allowable notation, okay? But what if I wanted to have a slightly different expression here all the way through? Or I wanted to actually have a variable right here all the way through. There is a data type called slice. And this data type slice takes 2 values, and it is the data type which is going on right inside here. So another way of writing this program, so I'm just doing that for simplicity right now, is to say the slice I to I plus 2, this thing is what's inside this thing. These are what slices are. So what I can do is I can then print the slice. Okay, so let me stop here for a moment. Oftentimes you will find a need to have this slice operator itself be a variable, something you can pass around, not just two parts, but you need to pass around the slice as a thing. Well, the slice itself is a thing. It's called a slice. It's a slice object. It's got a beginning and an end. And what you can do is you can define a variable called a slice, and that can be used all the way through. The third value here is the skip. So start, stop, and skip. If you put in the third number, what that does is it allows you to do every second value, 0, 2, 4, 6, which is what that third value happens to be. Anyways, there is a slice operator, and from time to time, people need that. Okay, reductions. There are a number of functions which take a sequence and reduce it to a single value. So as long as it is a sequence, a list or a tuple or anything you can do comparisons on, what it will do is take that list and then operate on it like you're going through it, like a iteration. Look at the first value, the second value, the third value, the fourth value, and sum will pick the largest. Min will pick the smallest. Max will pick the largest. This will pick the largest value in this list based on alphabetic sorting. So world is further along in the alphabet than hello. So anytime you've got a sequence, there are operations like sum and min and max, you can do it. Knowing about these functions is helpful because, oh, I want that to, I don't know how to make that go down. View, I don't know. Whoa, what am I doing now? Now I'm hitting buttons. Okay, fine, I'll do it this way because it flipped through. I obviously hit some sort of key combination to make that happen that I cannot figure out right now. Yep. Yep.
I think you can drag it next to
I thought I could drag it too, but no. I hit some key combination that I just can't.
That locks it in place.
Yes, the editor is different than the terminal. Okay, I don't know what I did. I hit something. I hit some button. Yeah, because I don't want a terminal there. Well, that's just weird. Okay, we'll go up to Python here. So this idea of a sequence reduction, this is knowing these functions is an alternative to having to do a iteration over a sequence. So you could always write your own function that iterated over a sequence. So let me just do this here as a demo. Let's say I had some sequence, 1, 2, 3, and 4, and my goal was to figure out the maximum value. Well, you can, it is allowed to say like max value equals 0 for item in S if max value if item is bigger than max value, then we say max value is equal to the item. And if you've done any programming, you know that what this program will do is figure out the largest value in the sequence. Okay, you can write code that does exactly the same thing as the max function, but these are going to be much faster than looping through things. In a language like C or Fortran, there's absolutely no difference between writing this out and doing this function because the function is going to do the same thing. In Python, because Python is an interpreted language, this line, this sequence of doing this thing and then the comparison, this is going to be much slower for the computer than doing a function like this. And the reason is when Python goes and executes this code, it's actually not executing Python code. It's executing C code behind the scenes. And this order operates much faster than these kind of things. But sometimes you do need to iterate over a sequence. And this is where you'd use this kind of construct. where you'd say, okay, I got some sequence. I'm going to iterate over it, the first thing, the second thing. So this is another thing about sequences. You can iterate over sequences. You can say for some variable, and this variable will take on the value of each element in the sequence all the way through. And because of this functionality, in Python, we don't need to index our things. We don't need to say, for I goes from 1 to 4, pick up the first item, the second item, the third item, the fourth item. We can just say, I just want the first thing, the second thing, the third thing. And so that's a very common Pythonic idiom all the way through. So the basic structure is for thing in a sequence, do a list of statements. Every time you write this, X is being replaced with whatever the next value is in the sequence. We didn't talk about it, but for, sometimes you want to end out of a sequence. There is a break operator. What a break does is, even though you're inside of a loop, if you get to a break, just stop going through the loop and immediately jump down to here. And a continue says, if you're going through something and you hit a continue, ignore the rest of the loop and just jump up and do the next line all the way through. So if you're familiar with breaks or continues in other languages, they're there as well. Now, something that I haven't demoed is if you want to do a loop through a bunch of numbers, okay, and I'm just going to stop. I really want this to be down at the bottom, because I just want it. It's important to me, because I want to be able to see my stuff, and I don't know what key I hit. Yes, thanks. I know it's a new integrated terminal. Okay, well, we'll do it this way. I'll just flip back and forth. I'll get rid of this one. If you're doing a loop, right, I showed you this notation. Well, it very quickly is going to get boring to write those out. So there is a function called range. And what range does is it gives you a sequence up to but not including that number. Now, range in general actually has 2 arguments. And what it does is it's a sequence that goes from some number up to another number. Okay, like any sequence. Okay, so if I do something like this, this is itself a sequence. So I can iterate through it. What do I mean by iterate through it? For I in S, or range 2 to 10, print I. Okay, this is the sequence 2, 3, 4, 5, 6, 7, 8, 9. So range itself is giving you an iterable. It's giving you the sequence from some number to some number. If you want to know what that is directly, I say range.2 to 10, it's a range. We can always turn one data type into another data type. So this is a list of a range. And you can see that what happens is it goes from 2 up to, but not included, 10. Range, if you don't give it a starting number, starts off at 0. And it always goes to this final value. If you give it like 10 to 3, you're not getting anything else, because if you started at 10 and go up, you're not going to end up at that value. But it does have the ability of stepping any which way you want. So if you want to go from 10 down to 3, step by -1, that's how you can come up with a list of 10, 9, 8, 7, 6, 5, 4, right? Up to, but not including the last value. Like slices, you can actually have your range skip by any number you want. So 10, 8, 6, 4. So using range is a nice way of being able to go, say, from 0 up to 100, skip by 5. And so this would be the sequence 0, 5, 10, 15. I'm doing a list just so to display it. Without the list, it's not being calculated behind the scenes. But when I go and I actually loop through it, whoops, I in range, print I, it's going to evaluate each value in that sequence. Now, the reason they use this range notation, why range becomes a range, is it allows you to do absolutely amazing, like ridiculous things in terms of your loop. For let's say range. Okay, Python has no problem at all thinking about the idea of the sequence 0 up to, I don't even know what that is, 1, 2, 3, 4, 5, 6, 7, 8, 9, a quadrillion. That happens very, very fast because the actual list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that doesn't exist. All this range is an iterable, which is the sequence of 0 and then what's next. Well, the next thing after this is a 1. The next thing after this is a 2. So I'll make this concrete. I'll create that really, really long iterable. And remember we talked about next before? Next gives you the next thing in the sequence. Oh, it's not an iterator. Oh, what do you mean it's not an iterator? I thought for sure it was an iterator. Huh. Well, my mistake. I thought for sure that range was an iterator. I guess it isn't. But I have no idea how this for loop is working. Okay, that's different. Maybe it was an iterator in a previous version of the language and they've changed it on me. Anyways, we'll call that an aside. If you ever have to do a loop of a whole bunch of things, range is what we use. Range is the idea of going the first, the second, the third, and you can skip by 2. The start is optional, the step is optional, and the range goes through. One combination of ranges and iterating over items that we want to use a lot is sometimes we need to say, well, I both need to know the number of it, if it's the first, the second, the third, or fourth, and I need to know what the actual value is. That idiom is so common. What they do is they've added a function called enumerate, which acts as both of these things. So if I've got some sequence and I want to go through them and I want to know both the number of it, it's the 0 element, the first element 1, element 2, and I want to know what the values are, there's this function called enumerate. Thanks very much, Omid. You're probably right. I have to class that as an iter. That's probably what the for is doing. It's a subtlety of the language. What we can do is use enumerate, and what enumerate's going to do is every time it goes through this thing, it's going to give you 2 things back, and it's going to unpack them. You typically would unpack them as an integer, and then whatever the element is of that list. So for example, say what you wanted to do is to write a program that was to give you line numbers. Give you line numbers. So let's do that. Okay, so I'm just going to quit out of here for a second. So I've got some programs. So let's grab a program. So there's the bounce program. Okay, say I wanted to write a program that took this code but put the line number in front all the way through. So how could I write a Python program? Okay, so how would I do that? We could say with open bounce.py read text as f. So we have a line for line in lines, print line, right? So what this will do is display the contents of the program. If we enumerate those lines, okay, then we can do something like this. What the program is going to do is give us the line number and then print it out. Okay, so let's just take a look what this would look like. Lines is not defined. Oh, it's not lines, is it? It's F. Python line no. There you go. So there's the first file. the second line, the third line, the fourth line, the fifth line. And you could play with this. You could make it fancier. You could say, you know what? I don't want to have an end character in there. And when you're printing this out, you know, I really would like you to put zeros in front so that it looks a bit prettier. Right, all the way through. Oh, you know what? My line number program should start with 1. It shouldn't start with 0. So let's modify this. Right, so you could do something like this where line 1, like so the character that's being printed out is 1 bigger than the line number that the enumerate's giving. It's going to be a field starting with zeros and a 4. And so what we've done is we've written our own line numbering routine. Just as an example of somewhere where you'd want to use the enumerate. Okay, I talked about enumerate, I talked about tuples. Okay, and the point here is enumerate is really doing the same logic as the following, where we've got a counter, we read things in, and then every time we do it, it increments the counter. This is basically exactly what enumerate is doing. It's just doing it for us. It's a little bit more Pythonic. It's how people like to read it. And it does run a teeny bit faster. So not much to worry about. It's more readable. For and tuples. Okay, so tuples can be unpacked. And that's effectively what an enumerate is doing. If I iterate through this sequence, the sequence is 1, 4, the next element is 10, 40, the third element is 23, 14. I can unpack those all the way through. There's a flip of this, which is, okay, well, what if I don't want to unpack things? What if I have 2 lists and I want to go through them pairwise? Well, you'd use what's called the zip function to do that. So imagine I had the following data. I had a list, which was name, shares, and price. And I had the values Google 100 and 490.1. I could zip those things together. And what they will do is create me a sequence where it takes the first element of this and the first element of this and returns that as a tuple. The first element of second element of this, the second element of this, and returns that as a tuple. And so what that does is it allows you to take 2 lists and iterate them over them together. I'll just open up the Python thing here again, right? So let's say I've got my first list, list 1. Let's say it's a bunch of numbers. And I've got a second list, A, B, C. Oh, I know. A, B, C, D, E, F. That's another sequence, right? They're both sequences. If I zip these 2 lists together, okay, what that's going to do is give me the sequence. Now, it's a zip object like range. It doesn't get evaluated until you actually use it. So if I say list of zip of list 1 and list 2, you can see that what I'm getting is the sequence 1 in an A and 2 in a B and 3 in a C. But I can do this in a loop where I can have a number and a letter in the zip list of list 1 and list 2. Okay, so what are we getting here? We're getting these 2 lists. List 1, bunch of numbers. List 2, bunch of letters. What zipping is doing is taking these pairwise and putting them together into tuples, and then I'm unpacking them. I'm unpacking them so I is an I and A is an A. And so then I can do something like print, let's use an F string, I equals I, comma, C equals C, comma, there. So I can do these 2 lists together. Okay, so zips and enumerates, those can be helpful and useful. Okay, and now we get to some exercises here. Okay, just trying to think of the best way of using our time together. We can just talk about this really briefly. Hopefully you're doing this along as we're going through this thing. So open up a Python environment and just sort of check this, make sure this does what you think it's supposed to do, right? What is range supposed to do? It counts from 0 to 9. Okay, that makes sense. We showed that. I want to go from 10 to 0, skip by -1. Right? So it starts at 10, goes up to, but not including the last value. Go from 0 to 2. Okay, we've covered an example like that. We've covered sequence operations. We've done an exercise like that. This is a common thing that I see when someone is used to a different programming language and is trying to program that other programming language with Python syntax. This will iterate through all the values inside of a list, right? It works, but what is it doing? If you've got a list of things, so let's make up some data. Okay, so I've got some data. I know that data is 7 characters long. I can say for n in range, well, what do I want to range over? The length of that data. And then I want to print data of n. Okay, that works, but don't do that. Okay, and the author here is being really explicit. Not only does reading it makes everyone's eyes bleed. That's not a nice way of saying it's not very Pythonic. It's not how we do it in this language. It turns out to be actually very inefficient and runs much slower. Like think orders of magnitude slower. This isn't how we do loops in Python. It's how you have to do it in C, but Python is a much higher level language. If you do need the index, that's why enumerate's part of the language. Okay, so this section is going to finish off with something to do with enumerate. Specifically, it's going to take your PCOS program, which we talked about earlier, and lets you do some additional information. So rather than just showing an error that said, hey, there was a mistake, I couldn't do it, it actually is going to say there was a mistake on line 4 or a mistake on line 7. So what you can do is you can improve your program so that you've got this additional debugging information. So how would you do that? Well, you're going to use an enumerate as you go through all those lines so you know what line you're currently on. And finally, there's an exercise here to take the zip function and take those headers. And then when you're building a dictionary of all the data, what you can use is the actual headers in the dictionary. And so what you can do is you can take this row of 3 values, zip it with the headers, and you get now this construct, which is an ordered pair of keys and values, keys and values, keys and values. Zip returns this thing, which is a zip object. You could turn it into a list by using the list operator. Likewise, you can take that zip operator and turn it into a dictionary using the dict function. And what that does is it goes through this sequence and it says, okay, if you give me a sequence of key value pairs, I'll give you back a dictionary. And so you can see this is what the construct looks like. This bit of logic, having a sequence, which is a bunch of headers, and a sequence, which is a bunch of data, and being able to, in one line, turn that into a dictionary is a construct we use all the time in Python. This idea of you're going between lists and tuples and dictionaries and converting types. This is how Python as a language gets efficient, not just to execute, but to read all the way through. So there is a worked example here where they're asking you to actually do that so that PCOS, portfolio cost, is more Pythonic all the way through. So you can try that and apply this to a more complicated data set, which has dates as well, and see if you can modify the program to do that. an exercise here on you know what? Let's do this one together as a group, because this is sort of a little bit different. So let's just take 5 minutes here. I'm going to have you all do exercise 2.17, and then we'll take it up as a group. Let's just do that. So get your fingers doing some typing. Open up a Python terminal and see if you can flip this around so that prices get mapped to names, as opposed to the other way around. And the solution's here, but give it a shot, see if you can figure it out on your own. And we'll discuss it in, like, I don't know, 4 minutes. 4 minutes. And while you're doing that, I'm going to figure out why my terminal is not in the right spot. So you're going to invert a dictionary. Okay, hopefully you've had a chance to play around with this. So this particular example has you create a dictionary and just try out what .items do, .values do, and .keys do. So dictionaries are these key value pairs. .items gives you all the key item pairs as a sequence, right? This is what the square brackets represents. First thing, second thing, third thing. Values gives you out only the keys. Sorry, try that again. Values gives you only the values. Keys gives you only the keys. And so if I wanted to invert this dictionary, what I could do is I could use a zip to say, take every value and map it with its corresponding key, and that would give me an inverted dictionary. Now, whether or not I wanted to do this with a list, I could also do this with a dictionary. If I wanted to do the lookup, right? You can imagine that, I don't know, we don't do this anymore, but you know these old things that we used to have called phone books, right? John's phone number, was 709-231-0454, and Sarah's phone number was 705-480-2703. Okay, you remember doing? You remember going? Oh, whoa. Okay, let's do that. Phone book. Like, you know, there used to be these books you'd have to get, the white pages, to look people's phone numbers up. I don't know. Does you even have a copy of the white pages anymore? But we get it every year, and I throw it on a table, and then every year I pick it up to throw it out when the next edition comes. I never use it. It was all online. But there was another book you could get back in the day that was not ordered alphabetically by people's names, but you could pay money to a company, and they would send you a copy of the book, which was ordered by phone numbers. And it was called a reverse phone number lookup. Like, this is when caller ID would give you the number but nothing else. Well, you basically could write your own reverse phone number lookup by taking a dictionary, like phone book, and then I could say, okay, what I'm going to do is I'm going to take my phone book values, and I'm going to take my phone book keys, zip those two things together, and get a dictionary. So I can call that the reverse phone book. Okay, and now instantly I have the ability to be like, who is calling me from number 709-102-2034? Who is this person? Oh, not reverse. Reverse phone book. Reverse phone book. Hey, John called me, right? So you could imagine a use for doing these things. You could also use this technique to do any operation on the values. So if you wanted to do the min or the max or sort something, when you're sorting items, it'll sort it based on the first element of a tuple. So you could find the largest stock price or the smallest stock price or some variation like that. Okay, let's continue on. Okay, so we talked about sequences, right? So sequences are ordered lists, tuples, lists, strings, all of them sequences. There is lots of other data structures out there that you may want. And so I'm not going to spend much time on this, but all of the data structures and that you can think about implementing are probably already worked out in Python. So queues and stacks and double-ended queues and different hash maps and things like that. They're probably already in Python. And so there's this whole module called collections, which are data types that have other features other than just lists and dictionaries and things. Now, internally, they're built up from dictionaries and lists and tuples, but sometimes you need these functionalities. Suppose what you wanted to do is you had a list of things and you wanted to count how many things there were, right? You were, I don't know, you were trying to do groceries, right? You wanted an inventory, right? You could imagine that you could have an inventory that was like how many apples I have, oranges I've got, how many grapes I have, right? I don't know. You can imagine you're writing some database. You want to have a count of how many things there are. This works. You can sort of do a lookup, but there's actually a data type which embeds that idea through it, right? So let's say you have to do an operation like, I want to find the number of apples and increase it by an order of a certain number. What I could do is I could use a counter object so that code like this would work. And effectively, a counter is just this concept of a bunch of things having values to them, right? So this is just an implementation of this basic idea where a counter, the idea is every variable in it has an associated number, right? So what you can do is you could write this. Now, what is a counter? A counter is really nothing more than a dictionary of keys attached to numbers. It just implements the functionality or the concept of all these things. And I think there might be a few other built-in methods that you care about. Another one might be one-to-many mappings, right? So say what you need to do was you had a dictionary like this, okay? So here's an example of a dictionary. Google maps to here, IBM maps to here, cat maps to here, IBM maps to here. Okay, now here's the problem with this as a dictionary, right? So if I just take this data and I consider it to be a dictionary, okay? Oh, well, that's not what I wanted, because I wanted to split these two up. Well, I'll do it this way. For, I'll say holdings. I'll do it with the dictionary first. So this is an empty dictionary. For name, shares, comma, price in portfolio. No, folio. Okay, what do I want to do? Holdings, name equals, or equals shares, comma, price. Okay, so that works in the sense that Google becomes this, IBM becomes this, cat becomes this, but we've overwritten and we've lost the data for the first record and the second record. And you could imagine doing something more complicated, right? You could imagine saying, okay, what I'm going to do is say, if name is in holdings, okay, if I already have that key, then holdings of name append shares prices, okay, else holdings name equals this list of shares dot prices. Okay, and what did I do wrong? This is from, okay, I want that. I want an if. I want that. I want an else. Oh, I just swapped them around. A tuple doesn't work. Okay, what I'm going for is you could write code that handled the case where the key didn't exist already or the key did exist, and you get some construct that looks like this. Instead, a default dict, which is a data structure in the collections module that handles this idea that dictionaries can have multiple values. So now, when you run this bit of code, your holdings of IBM will have the first value received, the second value received. What default dict does is ensures that every item has a value. It doesn't matter if it exists or not. So if I go and I create some default dictionary, so holdings equals default dictionary, I have to give it what the default is, and the default is an empty list. So, right, from collections. It has to be a callable. So what's the initial thing? Well, it's a list. Okay, so holdings by itself is a default disk where the default type is an empty list. And that means that if I ask for something which is not already in set, it gives me back this empty list, which means I can always take that and add to it some data. And that makes sense, okay? So what's going on here is by default, if the item doesn't exist, it's going to return back an empty list, and lists can be appended to. So it handles the logic of creating keys that you need all the way through. a history of things. It's related to a queue, a deck. Decks are sort of like queues. Not entirely sure what the difference is right there. But anyways, collections is one of those cool lot modules that you don't think about, but as soon as you know it's there, you know that it solves a whole bunch of problems. Almost for sure, most of the code you'll ever write in your life is not original. Most of the problems you're trying to solve have been solved before, potentially even a way that you don't know how to solve it. Collections is a module that contains a bunch of data structures. So the next time that you're trying to solve some algorithm or you're trying to do some problem, it may be useful, beneficial to take a look at the collections module. Here we go. This is exactly my point. Commentary. The collections module is one of the most useful modules in all of Python. In fact, we should do one just on collections. I'd put collections on your list of bedtime reading. So on that note, and I'm just going to stop sharing this one, I want to talk a little bit about documentation. So let me find my button, share screen. Yes, I accept all the cookies. That's just fine. Okay, Python documentation. Okay, let's talk about documentation for a moment. So the Python documentation, docs.python.org. This is like the official canonical documentation. It is useful. You should know where it is. You should go to it and take a look at it. There's the actual language, but there's also this thing right here that says the library reference. This is how people look up what this language can do, not just its syntax, but what it can do. And it's got all of these built-in libraries that are guaranteed to be there. We sometimes say Python is a kitchen sink included library. Here are all of the modules that are just built into the library, the language, they're there. So here's collections, right? So we talked about collections. So here are the collections which are here. So there's a deck, there's a counter, which we talked about, a default dict, but there's also an order dict if you need to have sequences and defaults as well. Chain maps. It is useful to just browse through here and be like, someone typed that up, someone implemented this, because there can be a functionality in these modules, which is useful. There's a lot of modules, and you can browse through these things as your heart desires. Say you're doing something with graphs. Well, there's a graph library. The other one that I always come across as being like, I discover it and realize that it did all the work for me. So collections for data types. And in terms of algorithms, I'm just going to give a shout out here to a function called itertools. Okay, itertools is part of functional programming. There's often things where you need to have a loop and you need to do something with a loop, right? So say, for example, you needed all the products of A, B, C, and D, right? Where you wanted A and B and A and C and A and D and B and C and C and D, right? And you need to look at all the different combinations of it. Well, there is a function called product in the itertools library that produces that sequence. There is a function that produces all permutations of this, or all combinations of this, or all combinations with replacement. So itertools is another library that I would at least be aware that it exists. It can handle counting. It can handle accumulation, so how many times like unique does. It can handle different maps. This is just a fun module to be aware of and browse through. So this idea of learning about modules and like, well, this is too much. I'm not going to sit down and read all this kind of thing. I wonder if this is still out, but I know at least a little while ago, there used to be a site called, yes, Python 3 Module of the Week. Okay, so this is sort of a little thing where what he does is when he was doing this series, every week, he would give you a little article on that string. So let's just take a look at collections, okay? And so you can see that what he's doing is giving you a little snapshot of that information. And every page is a little bit of documentation going, chain map, what's a chain map for? It's giving you a description of what a chain map is, okay? The sequence of dictionaries. So things become things become things. And what can you do with it? So it's giving you some examples of what it is. Counter, right? Count cacheable objects. It's not the documentation. Remember, the documentation is the standard library, and it's very dry. It's like specific. It tells you the right answer, but nothing else. So where was I lost it? Collections. So the official documentation will give you the documentation of what this does, but it doesn't explain how it could be used. Python module of the week, I find is a great use for learning about, well, how would I actually use this in practice, right? It gives you some documentation. Here's what it's for, and here are some use cases where people typically use these things. So if your goal was to learn more about how the standard library in Python, what it has for you, you could go through and you could just read these things once by once. And originally this was a website, and I'm now learning right now, it turns out he went and turned it into a book, which is a totally useful thing. But I think all the documentation is there. Just a neat way of going, well, what's in here? What's available? Anyways, browsing the documentation is a key part of learning any language, and just being like, what else does it do? What can I make it do? Because you don't always know to ask questions. Python's been around for 25 plus years. Most things that you need to do have already been implemented. Take a look at the standard library before taking the time to implement your own version of an algorithm or version of a data structure. It's probably there. Anyways, that was just an aside that I thought was useful to talk about. Okay, list comprehensions. Let's just talk what a list comprehension is. So list comprehensions are used to do things with a list. Okay, what do I mean? What do I mean by that? Let's say that okay, I'll just clear this out. Okay, just clear this out here. Let's say that your goal was to construct a list of squares. Okay, so that's what this example is. So what you want to do is you want to start with a list of numbers. Okay, so here's my my values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then for each one of these numbers, I want to come up with the square of it. Okay, so I'll say squares squares. Okay, I can have an empty list, and I could say for number in that list, squares append x times x. No. For number in x, number times number. There you go. So squares. Okay. So what I've done is I've looped through a list, and I built a new list where every element of the original list maps to another element. So 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 8, right? Okay, you could have another sequence where you've got a bunch of data, and you want to add a number to each of them, right? So if this is some output, you could say for n in x, and you want to say y, append all these things, you're going to say n plus 5. Okay, so you started with x and you ended up with y. And the idea is the pattern of going from every element in a sequence, coming up with a new sequence, is very, very common. We've discussed that for loops, because it's an interpreted language, right? Telling you, because Python is an interpreted language, for loops are inherently slow. So for this example, it's really not a big deal. But let's imagine I wanted to do the sum of squares, okay? And I wanted to go not just to 100, but to, I don't know, 1,000,000 squares append x times x. Okay, even that wasn't too bad. Okay, 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. That's too long. I wanted something that took some time, but not too much time. There, you saw the pause. It actually took a noticeable amount of time. 1, 2, 3. Good. Okay. So this idea of having to loop through something, it takes an amount of time. Computers do billions of instructions per second. It can do this operation a lot faster. And the way you can do it a lot faster is to use a list comprehension. So a list comprehension, what it does is you're assigning this variable squares, and then you're saying what I want every element in this list to be. Well, I want every element to be the square of something for x in range, and I want to make sure I get the same number of zeros, so I'm being honest in terms of the demo. Here we go. So this is what's called a list comprehension. It's syntactically identical to this construct of having an empty list, and then what you're doing is you're adding to it all the time, going through these steps, adding, except for now, what you're going to do is say this whole thing's going to be a list, but I'm going to iterate through it. That guy, which for whatever reason, oh, there you go. It's noticeably faster. And so for lots of programming, you'll find that these list comprehensions are faster than these combinations. Also, they're more readable. They very quickly give you the idea of jumping through a list, and you can see it in one go. So here's just examples. What you're doing is you have a list. This is a list comprehension. You can think of it as a loop built into a list. Here's one with strings. I've got a sequence of names. For every element in this list, I want you to have the new elements have this pattern, right? Where it's going to be the lowercase. So you can put anything you want in here all the way through. In fact, let's say I've got some list. Okay, names. Let's just do their example: Jake, Smith, and Bob. Okay, I can create a new list, and I can put anything I want here. Okay. In fact, I can put anything I want. Okay. So I can have a dictionary, like name. My dictionary is names, name. I don't know, occupation, unknown. Yeah. So the point here is you're looping through. Whatever goes here is an element of that list. And so you see I have this now sequence where this is the first record, this is the second record, this is the third record. In one line, building complicated data structures. But there's more. With a list comprehension, you often want to say, well, you know what? I want to do this, but only for the names that are special, the names that I know. And so what you can do is you can do a filtering. You can say, do this thing for every element in the list if this condition holds. Because so what would that look like for my example? If, now it's whatever the condition is. So if the length of the name, let's say the number of characters, right, is less than 5. Okay, so there's my condition. So here's a long one. For every name in this list, and there's the list, identify name. Go through them, check this condition. If the length of characters is less than 5, not that one, yes, that one, not that one, yes, this one. If it is, create these items. And so I get Jake and unknowns. So if you just wanted a list of even numbers, you could say, okay, I want numbers x for x in range of 10, 100, if x modulo 2 is equal to 0. So those are all the numbers that are not divided by 2, right? You're basically only including numbers which are not equal to 0. You can do like a series of Aristophanes with this thing. Look for prime numbers. Take a list, loop through them, remove all the divisions of 2, divisions of 3, divisions of 4. That would work. List comprehension are really useful. They are a good way of grabbing out certain fields out of a dictionary. You can imagine stocks being a list of a dictionary or a list of dictionaries. And so this is grabbing one field out of it. You can start to do queries with it. This is basically the beginnings of a database, right? Imagine stocks was a list of dictionaries. Here's a query, okay? Give me all the stocks where the price is bigger than 100 and I have at least 50 shares. You can combine these things all together because this is a list. So you can do a sequence reduction on it. How much money do I have in my stock portfolio? That's in one line. You're iterating through all the stocks, calculating something on the fly, the value of it, and then adding it all together. So rather than having to do a loop, 3 or 4 lines of code, this in one go is evaluating something about a structure. So this is a very powerful notation. You'll see this. It's one of the reasons people like Python. It's very expressive, gives you what you want. This idea of a list comprehension is equivalent to the code all the way through. And there's a little bit of history here. Where they came from was this idea of a set. If you ever did some math courses, you may think of give me the set. There is also a set comprehension, and there's also a dictionary comprehension as well. You can loop over dictionaries. You can loop over sets in a similar notation. So I believe actually a syntax very close to that also exists. The exercise to do with this is take your report.py program you're working on through this chapter and implement some list comprehensions in it to clean up the code, to make the code a lot tighter so there's less stuff you need to have all the way through it, and write in some queries all the way through. I don't think there's anything interesting in here for us to talk about. Okay, I'll just summarize this commentary. List comprehensions can make your code very efficient. Okay? It can allow you to have several lines compressed down into one line. In fact, you can even write comprehensions of comprehensions. And it can be fast and it can be efficient. But the warning here is to keep your code readable. Okay? It doesn't mean you should have your whole program should be a single comprehension, a single list inside of a list. You can do it, but then your code isn't going to be readable. It's not going to be maintainable. It's okay if you use several different comprehensions, you break it into a loop if it makes it more readable. However, it is really useful, especially for one-off kind of things where you've got to do data imports, data cleaning, data extractions. It is a really nice tool. In fact, I find that list comprehensions, once you have list comprehensions as a tool, there is very little that I find myself having to go back to bash and using bash loops or cut or matching that I can't just do with a list comprehension. You take some text, turn it into a list of lines, you do a list comprehension. It does most of what we need inside of a language. Okay, so this finishes off everything we need to talk about in this chapter. The last bit is on objects, and I'm going to just sort of skip this in the sense that I don't think it's overly relevant to what we're doing. All the things we've been talking about, strings, lists, dictionaries, collections, they're all objects. So objects are just things that exist inside of a language. They take up some memory. They have operations associated with them. And this section is talking about what those things actually are. And it's distinguishing between the variable identifier, this reference to it, and the underlying thing that takes up memory, the object in memory, and wants you to just be clear about what it is in memory. And so it goes to this argument. It says, well, when are two things the same? Well, 1, 2, 3 is an object. It's the list object 1, 2, 3 that's out in memory. And when you say A equals 1, 2, 3 and B equals A, well, because A and B are just references to this object, A and B are really pointing to the same thing. Okay. Now, because they're pointing to the same thing, and there's an is operator to check whether or not A and B are pointing to the same thing, this is important because you can get into a bit of trouble sometimes. Let me demo this out. Here is, okay, A equals 1, 2, 3. B is equal to A. Okay, so if I print A, I get 1, 2, 3. If I print B, I get 1, 2, 3. If I update A and say A value 2 is equal to 9, and I take a look at A, it's now 1, 2, 9. But because A is the same as B, if I print B, B is also 1, 2, 9. So this is an important thing about how these immutable data structures work. A and B are not copies of each other. They're just references to the same underlying thing. In memory, they are pointing to the same memory location. Okay? If you want to have a copy of something, that's a different thing. Okay? A copy of things is a different idea, right? So there are ways of doing copies, and there is a copy module that handles this kind of stuff for you. If you truly want to make a copy of something, you have to create a new data structure which has all the same values in it. So what could I do? I could take the list A, and I could make a copy of it. And I think you could use copy.dcopy if you wanted. The other way of doing it is just to create a new list, okay, and then replace the contents of that list with A. Okay, what? A is these numbers, B is these numbers. They may look the same, but I haven't done the same thing. I've taken a new data structure B and copied the contents of A into B. So now if I say A is equal to B, that's false. The memory represented by A and the memory represented by B are not the same numbers anymore. They're still numerically equal, okay? But they're not representing the same location in memory. Now, this idea about memory and how it's being used, work through this just so you're aware of this detail, but don't worry too much of it, especially if programming is a concept new to you. If you are familiar with programming and memory management, this might be useful information that you want to go through. But other than this, just let's clean up this idea of data types and read through this on your own. Okay. Whew. So that completes exercise chapter 2. And really what you're doing in chapter 2 is you are modifying and working on this program called report.py, which is the extension of PCOS. It's basically saying a portfolio thing. And I'd like you to complete those exercises. So this is what the next assignment should be on. I'm going to say, I'm going to say it's due next class. That's sort of what we're working on right now. So let me give you some time right now today just to start working on some of these exercises. And we will go through and, no, what should I do? What's a good use of time? Okay, so step 1 is you're supposed to be working on these things. I also want to get through this next section. So this is a much shorter section. I can get through this before the end of the day. I'm just trying to think about how to use our time well. Here, let's do this. Let's take a bit of a break because we've been talking for a little while. So I'll just say back at, well, I got an hour. Let's do a 15-minute break here. So 2:45 NL. So let's just take a bit of a, no, that's wrong. That's wrong. Right now it is 2:45 NL. Let's come back at, is that right? Is that 15 minutes from now?
Yes, Professor.
Okay, so I'm just trying to, let's come back and we'll spend the last hour plowing through this material. But what you can do in the next 15 minutes, besides like stretching, take a look at the exercises in assignment 5, really, which is just the questions or the problems inside that previous section, and make sure there's nothing in there that's going to cause a problem for you or that you'd like to discuss before we leave. So if there's anything there, I will say that assignment 5 is due on Thursday. I'm not particular about due dates. If you can't get it done for Thursday and you get it done for like Sunday evening, that's just fine. But the expectation is you're working on this Python stuff. We'll come back in 15 minutes and we will finish off this introduction to Python thing with this short module. That's the plan. So I said, I'll see you guys in 15 minutes. But do take a look at anything from chapter 2, just to make sure there's nothing in there that's going to give you a pause for thought. Excellent. Thanks. Okay, I think it's time for us all to get back to this. Phone's still working. I think it's still working, hopefully. Okay. Share the screen. Okay, so what I want to do is just talk about a few more things about how Python is put together in terms of how functions become modules. So let's do this. When we've been writing our program, so when you work on a program like, as you're going to in chapter 2, report.py, that is what we call a Python script. It's sort of the base unit on sort of the files of how Python programs are put together. The defaults or the expectation is the extension is .py, and they are runnable by a Python interpreter by just passing them in on the command line. So when you do something like Python space report, what that does is it goes through this file and executes every line that it sees. Okay, so this program right now has nothing inside of it, so nothing happens. And if I gave you some code, it would start executing the code line by line, right? So if I was to say x equals y, y equals 2, z equals x plus y, those are 3 statements. So if I ran the program, this line would execute it, then this line, then this line. And of course, to do something useful, we'd have to print out some output. So each line is executed one at a time. As you write programs longer and longer, typically you want to try and organize what's going on. So we talked about functions before, that you can take some functionality and put it together inside of a script. Okay, so we can have maybe a function that takes the square of something, right? And it does whatever it needs to do. And now what we can do is say, okay, well, that's of x and the square of y. And we've talked about this before, that what functions allow you to do is come up with reusable components for your program. So again, what's going to happen is when you run this through an interpreter, each line gets interpreted. The comment gets ignored, gets ignored, gets ignored, death. Okay, so at this moment right here, what the interpreter is going to do is say, okay, you are telling me there is such a thing as a square. No problem. Then what it's going to do is actually jump to line 7 and keep on going. Okay, there's a x equals 3, y is 5, z is a square. Oh, wait, you told me what a square was. Then I go up here and I actually execute that content. I figure out what square is, then I go to square, and then it jumps up here and executes that content. And one of the things that means is, okay, if you have an actual mistake in your code right here, when you go to run that program, okay, you'll get a, okay, sorry, I should say, it does syntax checking, but it won't, yeah, let me, I will do that. Okay, so when I actually go to run this program, I'm getting an error because you can't take string and add it to a number. But where that error is occurring, yes, it's occurring in the square function at line 6, but only after it gets called on line 11. And so what that means is, if I just get rid of this line for a moment, z equals x plus y as before. So look at this program. I define square. Square does this thing. Then I say x equals 3, y equals 5, z equals x plus y, and then z. If I was to run this program, what would happen? Well, it works. And it works because when it tries to evaluate this piece of code, this code never actually gets run. And I don't even think, I'm trying to remember how this language works. Okay. Sure, it's valid Python, but won't actually execute that code until you get to it. So it's reading through the whole definition, sure it knows what it is, but you can't find mistakes in it until you actually call the code and run it. The order is important. So if I was to do square of x, square of y, and I'll fix this mistake. Okay, the order is important. So we'll do this, we'll run the program. You should get 34. Yep, it works fine. The order is important. So if I take that definition and I put it down here, whoa, try that again. D3D, okay. If I do a program like this, what I'm doing is I'm saying, okay, x equals 3, y equals 5, z equals the square of x. Python's reading all scripts from the top to the bottom in order. And so when it gets to square, it's going to say, I don't know what square is, even though it's going to, you're going to tell what square is later on. Unlike in a compiled program, which reads through the entire program, links it together, compiles it, links it together, and then runs it, Python is only able to interpret it up to this point. So the order is important. What that means is in scripts, we almost always put definitions of variables and functions near the top, or at least immediately before where they're needed. Okay, when we're defining a function, we want to try and put all the code we need to deal with that function in one spot. So if we have a function like read, the code that's required to read the prices in sort of one logical group, right? To read prices from a file, you'll need all the code that does that in one block. You wouldn't split this up into different parts because it's sort of an atomic whole all the way through. What allows you to do is two things. One is that it gives you reproducibility. So you don't need to repeat yourself if I want to read in the old prices and the new prices. But more so, it gives you a level of abstraction. I don't need to think about the details of how I'm reading the prices in. It's sufficient for me just to know that I'm reading the old prices and I'm reading in can be used inside a function. Okay, so if you want to, you can import libraries, you can call help. In fact, you can put inside of a function let's call this the f function. Okay, so what I've done is inside of square, I have put in a valid piece of Python code, f of y. So now I can say x times f of x. Where does f come from? It gets defined inside this function. Now, this will work in the sense that the code will run. But if I try to do f of y, this will fail. Why? Because f isn't declared in one of these lines. Again, the way that these are read is first line, second line, third line. Okay, I'm defining what square is, but I'm not actually going to run it until I need it. This, and this f only lives inside of this function. So it's not scoped globally. You can put any statement you want inside of a function. There's no special statements. There is nothing you cannot do inside of a function that you can do inside of a script. A function is just a thing, a variable that you carry around. Functions, because the way that they're defined is they read the def in first and then the bar. You're allowed to actually do something like this where you say foo of bar and bar of statements, or bar of statements and foo of bar. Why are you allowed to do it this way? Because what the interpreter is doing is it's reading that first line, then it's reading the second line, and then it's going to execute the program, and it's already seen both the definition of foo and the definition of bar. So the order in which you define things is important in terms of the calling, not in terms of how you write your code. This opportunity leads you to one of two different programming styles. Okay, so the idea of a programming style is it doesn't really matter which way we do it. The language doesn't force you to do it one way or the other. But there might be a convention in how you're programming and with the other authors you're working with on whether or not you should write your programs like this, or you should write your programs like this. Okay, so in a bottom-up style, what you have here is you have the lowest level, simplest functions near the top. So what you do is you think about your program and you say, okay, well, to write my main program, I'm going to need a function called foo of x. Okay, whatever foo or bar or span happen to be. It doesn't depend upon anything else. But then I'm going to write this other function bar that depends upon foo. And because it depends upon it, I'm going to put it further down in my code. Remember, Python doesn't care. I could put these three functions in any order that I like. It's just that in a bottom-up style, we think about the functions as being building blocks, and so we put the simplest stuff at the top. That's a style choice. Some authors like it. Some authors do it a different way. There's also a top-down approach where what you want to do is you think about the program as being sort of some fundamental large piece, and then you define all the little functions you need below. That would be a top-down style. Bottom-up is more common, and so that's the model we'll sort of go with. When you're reading a piece of code, think about it as introducing pieces of functionality. This is like in mathematics. You do lemmas and theorems. You put in the lemmas first. You say what you're going to need to be able to understand the later program. Functions. Functions are typically treated as black boxes. And so what that means is you should be able to look at the name of the function, maybe it's docstring, and see what goes in and know and have confidence what's going to come out. So if I have a function here that is called square, I am expecting it to return the square of this thing. As written, this is a bad name for a function because it doesn't return the square. It returns the square times the value plus 2. It returns like a cubic of it plus 2x squared. So that is a bad choice of name because it's not very predictable. But more so than just the predictability of the readability, you wouldn't want your code to go and do something as a side effect. Okay? What do I mean by a side effect? I'll get rid of this side effect, but I'll give you a side effect. Output.txt write t as f.write out yeah, there we go. So there is a side effect for the program. Okay, so what it does is it squares the number, but it does this thing which is sort of on the side as well. So this is going to work. Okay, it doesn't work because I got rid of it here. Okay, but this is an artifact. This is something that the function is doing more so than just returning a function. So every time you call it, it's going to produce a file called output.txt, but it's always going to be overwriting that file. So this is something that's a mysterious side effect of the function. Sometimes in some languages, we distinguish between what are called pure functions, functions that are totally dependent upon their input and give you an output, and functions that are more like subroutines or procedures, like this thing, which does something. You should be clear what a function does. The name is a good way of doing it. The other way is to have a docstring. I would recommend that all functions have docstrings. A docstring is just a string that explains to a user what it does. Returns the square of x, and you can put in an extra comment. You can put triple quotes if you wanted lots. Saves the input x in the file output.txt for debugging. I don't know. You'd want to put that into the docstring so that someone using this function can read the first little bit and really know what this program is doing. Functions aren't always short. You want to have some information that guides the user to what it's doing. This is also what's driving the help. I think we talked about that before. some questions? Any questions? Some developers love types, and they bristle at languages that don't have strong typing. And so they like, so JavaScript is a language, right? Several of you probably programmed in JavaScript. JavaScript doesn't have a strong sense of typing, right? Variables can take on new types and you get types being changed. But there's a variant of JavaScript called TypeScript, which adds in explicit types so that when you compile TypeScript into JavaScript, it's able to do type checking. Python doesn't have explicit strong type checking. However, types have been thought about as something that really would help us avoid problems. So here's a function that only makes sense if x is a number. And so what you can do is you can add what are called type annotations to the program. Okay, a type annotation gives the developer a bit of indication about what's going on. So here we go. What I'm going to do is I'm going to say this variable, this really needs to be a float. And what it's going to return as output is a float. Okay, now again, I'm using that fancy font. I'm just putting a hyphen and then the character greater than. When they're typed together, my editor is making them look like one symbol. These are type annotations. And what they're doing is they're telling the editor that this function square takes a floating point number in and produces a floating point number out. Python as a language completely ignores this information. But where it gets used is it lets me find bugs before running them. So for example, if I was to turn this thing into the letter X, okay, this is a literal, oh, I thought it was gonna, I don't have Flex turned on. Okay, there are tools that I haven't installed that will automatically flag this as a mistake because I told it. I obviously don't have those tools installed. But there are tools that exist in different development environments that let you do type checking. Another kind of type checking is this square. Well, let's say I wanted to take square. I wanted to know what data type it was. So let's say it was, here, string of X. This as given may give me an answer I'm not expecting. So work directory, Python report. Okay, I can't multiply non-integer types of string, okay? That's because this function returned a string and I am trying to, no, it's this one right here. There we go. I'm trying to take a string and add it to another string. A string as an output. And there's various tools that help with these things. So if you ever see the colon float or the arrow thing, they're called type annotations. They're useful in code checkers. Okay, it's just writing better code, clearer code. I want to, okay, so here's what you're going to do with this information. Number one, you're going to modify that report program after you've finished everything in the chapter 2 so that it's split up into a collection of functions. You're going to create a function that takes all of the code relating to printing the report and turn that into a function, okay? And then, because we're going to practice a bottom-up structure, there'll be the last part of the program, which is a series of computations. Okay, so what does that mean? It means there's going to be a function, which is going to be read prices. A function called read portfolio. And again, I'm just doing path here. And then there's going to be a function called print report. Okay, so that's sort of the basic structure of this thing. And so you're going to want to do it so that you've got a, oh, I guess I need one more. Def make report portfolio and prices. So it's entirely possible that your program, and I'm not sure exactly what it's going to look like, but it'll probably look like this. So you're able to do something like file name, prices equals read prices data set slash prices dot CSV. Portfolio equals read portfolio data set slash portfolio dot CSV. Report equals make report. Portfolio comma prices. No, prices. There we go. And then print report, print report, print report, report. Okay, so here is an example of, without me typing in the whole code, it is doing some linting. Okay, report, where I define the functions. Each function does a specific thing, and you want to have a doc string and what it does. And then the bottom actually has no logic other than just stringing a bunch of functions all together, right? So that's the idea of that exercise. Okay, what's the next thing? The top level function for the program execution. Okay, so this itself is a whole bunch of instructions. Well, I could turn this into a function. I didn't say tab. Right? So there is one master program that does. Overall program is just portfolio report. Okay, so I'm just going to make this program a little bit dumber, and I'm going to say, give it some statements. Reading in prices, print reading in portfolio, print making reports, print printing report. Okay, so I just want to have something so that when I run it, you can actually see activity, right? So it does these things, right? It reads in the prices, it reads the portfolio, makes the report, it prints the report, right? So what do these pieces do? Well, the prices is some dictionary, right? The portfolio is another dictionary. Maybe it's a list of dictionaries. No, it's a list of dictionaries. Okay, and the report return is some report object, maybe it's another dictionary. Okay, so that you can start to see how the structure that runs all those pieces together. So now every time I run this program, this script, it does everything in it. It reads the prices, reads the portfolio, makes the builds the report, and prints the report. I'm back. Thanks very much. Thanks for waiting. Okay, let's share a screen and get this going again. I don't know why it dies. Okay, where are we at? Okay, let's talk a little bit more about functions, and I'll talk about modularity in a moment. Reading functions. So functions have this idea of arguments. So we've talked about this before, that whatever you put on inside the round brackets, that's going to be carried inside the function. So that's one argument, that's two arguments, and then these variables are known throughout the functions. You can call functions like this. I put in a literal, an actual value. Each one of them, though, gets mapped to the corresponding position inside the function. So that's one way of doing variables. But you know what? Let me give you a demo here. I'm going to say code funcdemo.py. I want to make sure this is clear. Nope. I just need touch funcdemo.py. Just need function demo. There we go. Okay, let me give you a function. Okay, so we'll call this def just the function one. Okay, let's say it takes two arguments, x comma y, and what it does is it gives you back x squared plus y, not user warning, plus y. Okay, so if I say x equals 2 and y equals 3, and then I say print function of x comma y, right? So that's a nice little program, and it produces 7 because 2 squared plus 3 is 7. Okay, now here's the thing about positional programming, is it's by position, right? You already know, or you may know, that the actual letters in here don't really matter, right? I can change this to being any letters I want. If I wanted to call this A and B, so this is the first thing, and this is the second. The fact that it's X out here has nothing to do with the meaning of it inside of here. This is just going to map the first thing to the second thing. So you're going to get the exact same answer, okay? The X, whatever the X is, it has a value of 2, is being mapped to this 2 and becomes here. What that means is this is actually completely valid code, okay? X, the position X gets mapped to the A right here. So A is equal to 2. The position here has a value of 3. It's mapped to the function variable X. So even though X is equal to 2, inside here, X is equal to 3. And that gets weird. So you can actually get some real weirdness. Like you can have a function that says x comma y. There's absolutely nothing that's stopping you from saying y comma x, okay? That's totally valid. It's not going to give you the same answer because we swapped the values of x and y, because it's just positional. You mapped one thing to another. Now, this can be okay, but sometimes you can have variable names that sound the same or you want to reuse them. There's another way of being explicit so the order doesn't throw you off, and that's to use what are called keyword arguments. With keyword arguments, independent of its order. Okay, well, what do I mean by that? If I say x equals 0 and y equals 0, okay, then what's going to, I can explicitly say what my value of x is and my value of y is. So if I want x to be equal to x and y to be equal to y, okay, so you have the correct way around. I'm going to get an answer of 7. Now the order doesn't matter. I can say y is equal to y, x is equal to x. And it's only what I want to be, that's supposed to be 7. It's only when I want to actually be explicit about, no, y is equal to x and x is equal to y, would I want that. Now order doesn't matter. Order doesn't matter whenever you have what are called these keyword arguments. So this is the keyword, x and y, and it's being mapped to a default value. What's a default value? A default value is just the idea that I could have some initial value in there, and if I don't tell you what y is, then I'm just going to use that default. So here's an example. Okay. So what's going on here? X is taking on the value of 3. So 3 squared. Y is taking on the value of 123. 3 squared, which is 9, plus 123 is 132. So keywords allow you to do these. Unmute myself, share the screen, and continue. Okay. In general, keyword arguments are more useful when you've got these short values. So for example, let's imagine that in your code, you came across a line of code that said parse data, data, false, comma, true. You knew that one of these was to ignore the errors, and one of these was to turn on debugging. Which one of these two corresponds to turning on debugging? Am I debugging is on or is debugging off? This is not a great way of making things readable. Keyword arguments allow you to change it so that you could say parse data, ignore errors equals true, parse data, debug equals true, parse data, debug equals true, ignore errors equals true. And you're allowed to have a combination of positional and keyword arguments. So in this case, what we're doing is we pass in a single positional argument and an optional keyword argument. So that's valid. If I pass in a second value, that's valid. But the one thing I can't do is skip this value right here. I have to pass in a positional value. And the only rule about positional values and keyword values is all the positional values need to come first before any of the keyword values. But you'll see that idea all the way through. There's some programming suggestions in the text here about giving meaningful names. You don't call functions func unless you're doing a really simple example. In principle, you give them names. You give them doc strings so you can read them. We talked about return. If you ever need to return more than one thing, you would use a tuple, right? And you pack them together. So you could pack a whole bunch of things together in one go. And if you want to return nothing, there's no return. Implicitly, what you're doing is you're returning a none. So one of the questions last time was, what's the purpose of none? None is just the lack of data. It's a special variable. If you just return, you're returning none. If you don't even have a return statement, you're also returning none all the way through. There's a bunch of stuff on scope. If you're familiar with other programming languages, I'm going to invite you to read about how Python handles scope. If programming is new to you, don't worry about it. Scope can be a little bit weird. Generally, use names only once. There are global variables in Python. If you don't know the difference between a global and local, just ignore that you see this paragraph. Don't be using globals. Globals are one of those things which you're never supposed to use until you know you're supposed to use them. It's like an advanced tool. If I lose the internet one more time, it's going to tell me, go outside and enjoy the sunshine. I don't know why it's failing consistently right now, but it is. One more shot. Okay, this is just to point out that when you're passing something in as an argument by reference, then the data is actually changed. So if you pass in the list 1, 2, 3, that 1, 2, 3, and it gets modified, it'll actually get modified outside. Functions don't receive copies, they receive inputs. There's an exercise for you to do that I want you to work through. Let me just talk about one more thing that I think is important. Okay, I want you to read about error checking, because that's important. I want to talk about modules. Modules is the last thing I want to make sure I cover. Once we've developed a bunch of functions, there's times when we need to write another program where we don't want to run all of this code. We only want to run some of these functions. So here is an example, okay, where you might have a function, a bunch of functions that you're using. Okay, so there's that. Let's add in a few more. Okay, so there's the grok function. It returns a G, and there's the spam function, and it returns an S. Okay, so there are some functions, right? It does something, and if I run func demo, right? Oh, I'm missing a conditional. I have the error. Okay, so there is a script that defines some functions. Okay, imagine that I've got no, I don't want there. I want pro demo. No. Open it there. Pro demo. Imagine I am writing a program and I want to reuse some of the functions from this program. What I can do is I can import and then I can call those arguments. I can say A is equal to func demo.grok of 2, B equals func demo of spam.1, and I can say print A comma B. Okay, so what's happening here is I'm bringing in all the functionality from this script so that it can be reused in this one. Func demo is a module. Okay. No, not report. Prog demo. Okay. And so you can see grok. What does grok do? Grok returns the letter G. What does spam do? Spam returns the letter S. And so if I print A and B, I'm just getting a G and S. Okay. So this is how modules are built up. And whenever we do import collections or import math, these modules are just built with a whole bunch of functions. Now, one of the problems here is there's some code which when I'm importing it, I don't want to run. So what I might do is I might have, say, I might come up with a another function, which is, say, called main. Oh, come on, keyboard. Right? Which defines this as a program. And then one solution would be when I'm trying to run my function demo, I call main. But when I want to import it, I could come along here and comment that out so that if I import it, that line, this main, doesn't get run. You can sort of play around with that kind of idea. By default, import is actually saying run a script. What import does is it runs all of the statements inside this script, including any lines that have side effects, any lines that actually do some work. Because sometimes you write scripts where you both want the function to act as an independent script, you want to be able to say Python func demo and act as a library. It's often necessary to put a little bit of code in here to protect yourself. I'll be very specific in this example. Let's imagine we are looking at our report program, okay? So this report program you're going to be working on, it's got a bunch of functions, okay? It's got read portfolio, make report, print report, portfolio, and then portfolio report. Imagine that I am writing another program where I want to reuse some of the functionality from the report module. Okay, I only really want to bring in the prices. I want to read prices, new prices.csv. So this is what I want to do. I want to write a program, and I want to reuse the piece of code that was inside this module, whatever read prices does. Okay, so here's my program. I go along and I run it. Prog demo. Read prices is not defined. Oh, modules, right? Because read prices isn't defined, it's actually in the namespace of report. So that's better. Okay, this is a bit weird. It read in the prices, it read in the portfolio, it made the report, it printed the report, and it read in the prices. Why did it do all of this stuff? Well, that's because when I imported report, the very last statement was this bit right here. All modules, all programs have a concept of a new hidden variable called underscore main. Okay, this variable is defined for every module, every .py file you read in. So I'm just going to show you what that is by running this program. And you can see that when I run this program, it says underscore name has the value of underscore main. If I put that same line of code into this module, no, go away. Print underscore name underscore. So we're inside the report module. If I run prog demo, import report, print name. Now its name is the name of the module. It's the name of the file. It's the report module. So that's what its name is. Alternatively, when I run report as a script, I say, what's the name of this thing? Its name is now main. Okay, so this is the distinction. When I run a program, the outermost script that's driving everything will have the name underscore main underscore. When it gets imported, a module will have it in the name of the actual name of the module. And so what that means is you can put the following piece of code in. If the name that I'm running is actually underscore main underscore, then run this piece of code. So only if this module is being run as a script, I want you to do this. Otherwise, ignore it. And so now, if I do a python.report, because name is main, I run my whole program. But if I run prog demo, then I read in the prices and run main. I don't see everything else because when I import report, it checks the name isn't main, and it skips it away. That can be a very helpful feature for bringing in different things. Okay, we talked about globals, modules are isolated, module extensions, module loading. Ugh. Read through it, but don't worry too much about that. That's going to be beyond the scope of what I want to cover. Okay, there are some exercises here where you're using pcost from the first chapter and bringing it in as a module. So you see how these programs are being put together. So at the end of the day, report.py and pcost.py and portfolio.py become a set of programs that are all one application used together. And finally, there is some text here about the main module, which is exactly what I was just talking about. the main underscore check. So you can just consider this to be the text associated with that code. And that's about it for these first 3 chapters. So I've gone through fairly quickly on this 3rd chapter. I'll invite you to read it on your own to give some idea. Language. So where are we at? I am going to leave you with completing the exercises in chapter 2, and then work on the exercises in program in chapter 3. Reading it and then doing it comprise assignment 6. Okay, so that will complete our introduction to programming, introduction to Python. There is tons more in Python. If you're keen, go ahead and look at a few other things. We won't need them for this course. If you need more introduction about programming in general, or in Python, you're like, okay, this is going over my head. I dropped a couple links into Slack that might be useful for you. There's hundreds of courses out there, but these 2 looked appropriate and fairly good. New share. Yeah, I'll just share my whole screen. Okay, so I just dropped these things into things. One is someone's gone and given sort of a Free Code Camp as a collection of tutorials. Here's a nice one that sort of is designed Python for non-programmers. So this is completely new to you. It's got like 2-minute exercise, like each one is a little video clip with this instructor guy, goes for a few minutes talking about what's going on, and then asks you a little question, just as another way of learning about it. If you'd like to learn more visually, here's another course out there that I've seen it before. Well, not the ad. I don't care about the ad. Here's a 4-hour version of everything we've been talking about if you need another go at it. And then there are text-based resources as well. So this is someone just doing really exactly what I just did. If you need other person of explaining it to you, be careful. The only thing I would say about Python resources is make sure it's a modern Python resource. You're looking for something that talks about Python 3. Don't try and find a whole book on it. Rather, try and build something with it and see how far you get. And remember, general channel, any questions? It's even better to put something in the general channel than to give me a direct message, because then, maybe one of your other classmates will answer the question. But the point of the last 3 classes problems. This is a computational science course or scientific computing course. So the idea is we're going to use Python to do some stuff. We're going to work some data. There are a few modules which are not part of the standard library that we need to cover. Okay, we need to at least talk about briefly Pandas, which is the Python data analysis library. That's incredibly popular. We should talk about NumPy, which is the numerical computational resources associated with Python. This is how we do arrays. Closely related to that is something called SciPy. SciPy is a whole ecosystem based on, among other things, NumPy, which lets you do all the mathematical software you need. It's basically, you can think of the SciPy as a MATLAB replacement entirely. And you definitely should know something about visualization. And so the standard, and there are other ones, library for visualization, graphs, and plots, something called Matplotlib. And so what I'll do is a little bit of a tutorial, introduction, summary of Pandas, NumPy, SciPy, and Matplotlib as things that other tools are all based on. So we'll spend a little bit of time just showing you what these things are and generate a few assignments based on that. And then what I want to do is take that pile of tools and apply it to some specific topics. So I'm a physical oceanographer. So I work with oceanographic data. So I'll try and design some extended exercise or example around that, where we take some oceanographic data, apply some stuff to it. Another domain which I think could be useful, and I'm just going to flip over here. Omid, are you in the session today? Or did you disappear? You are here. You are here. I thought we were talking about. We had a conversation a week ago. Omid, are you here? He's in the chat, but he's not responding back to me. Maybe he's off doing something else. I was talking about Python stuff. Anyways, for an example, and that's a shout out to him only because we were talking about this example. Suppose you were a scientist and you care about things like you cared about stars, okay? You wanted to go and get information about the stars. You want to know how many stars there were. And you did some searching and you found this site that says the Gaia Archive, okay? Well, what do I do with it? Well, there's a download page, okay? I can go to it. I can download the data, and it gives me to this rather uninspiring webpage where it's a bunch of directories. Oh, well, how do I get that? Notice the CSV file? That's what the data actually looks like. That's what scientific data looks like all the time. The data is often CSV or some other data force. So here is an example of some data. Now, each file is only 200, what is that? Kilobytes, mega. Every file is 200 meg. There's a few files. Okay, they go on for a while. So here's a question. How would you go about writing code to start to analyze this data set? What would you need to do to be able to do things like produce a histogram of what kind of stars are out there, analyze it in some way, reduce it down and make some visualization of it? There's a few pretty visualizations for stars built in to this site. It's going to visualize where stars are in the world. How do we build that kind of stuff? So something from astronomy, something from oceanography. We sort of, I don't know, there's something. We could build an application like this in Python. Those are color magnitude streams of looking at data in this data set. What I'd be interested from you as a group, is there a domain somewhere out there, like a topic of science, chemistry, computational biology, business, finance, that you're like, oh, that's my thing. I care about that. I'll draw an example from that area. Is there any particular realm of science that someone's got in their mind that they care about? Here. Okay, that's make some decisions. We'll make some choices, and I'll see you on Thursday. Okay, so what are you left with? Go finish off the first 3 chapters of that David Beasley course. Feel comfortable in into some application, and these applications are going to be the project. I'm going to take you through something. We're going to get to practice all these tools together, and that's the second half of the course. Just before we sign off here, okay, so we're all done. I'm going to stop the recording.
Sorry, Professor.
There's a question. Sure. Let me just stop the. I'm going to stop the share.